Hello students, hope you are doing good and staying safe in this pandemic situation. Before we move on to today's topic, let me ask you questions to you all to know about what we are going to learn from today's class. So, have you ever fought with your brother or sister about who is taller? Have you ever wondered if your pencil is longer than your friend's? Have you ever thought about which container would hold more juice? Have you ever wondered which object is heavier? Do you know how people know how much they have traveled or how much is the length of the chair? You can learn all these questions by learning measurements. Thus, you would have learned about introduction on measurements, the measuring tools, length, meter and the conversions, SI units. So let's just do a small recap of what you have learned in your previous class. So what is meant by measurement? Measurement is the comparison of an unknown quantity with some known quantity. What does an unknown quantity mean? Unknown quantity is nothing but a thing whose values or nature can't be determined or it's not yet known. Okay, so measurement has two parts, number and its unit. So you have seen the various measuring tools used to measure various objects. Your height can be measured by a measuring tape, your running time can be measured by using a stop clock, the size of a notebook can be measured by using a meter scale, and the amount of water that you drink every day can be measured by using a measuring jar. Next, you learned about length. So what is length? Length is the distance between one end and the other end. It is measured in meter and it is denoted by the small m. For large measurements such as to find the distance between two cities, length can be measured by using kilometer, and for medium measurements such as height of a cupboard or a table, or you want to find the length of the notebook, it can be measured using meters, and small measurements are done using centimeters and millimeters. And you looked into the meters and the conversions. So 1 centimeter is equal to how many millimeter? Yes, it's 10 millimeter. And 1 decimeter is equal to 10 centimeter. 1 meter is equal to 10 decimeter. 1 kilometer is equal to 1000 meter. You must be familiar with these conversions. And next, you looked into the SI units. So what is the abbreviated form of SI units? Yes, it is the International System of Units. So it is shortly abbreviated as SI units. So the basic measurements includes length, mass and time. So what is the SI unit of length? It is meter. And what about the SI unit of mass? It is kilogram. And the SI unit of time is second. So this is what you have learned in the previous class. In today's class, you will be learning about multiples and submultiples of SI unit. So what does multiple and submultiple mean? So submultiples means you're going to divide the value, and multiple means you're going to multiply the value. So can you see the tabulation listed below? So when you want to convert decimeter in terms of meter, you're going to divide by 1 by 10. For example, can you see here 1 meter is equal to 10 decimeters. So when you want to convert decimeter in terms of meter, you're going to divide the value by 1 by 10. Similarly, centimeter to meter is you're going to divide it by 100. So 1 meter is equal to 100 centimeter. So when you want to convert centimeter in terms of meter, you're going to divide the value by 100. And next one is the millimeter is equal to 1000 millimeter. So when you want to represent 1 millimeter in terms of meters, you're going to divide the value by 1000. Next comes the nanometer. Nanometer is generally represented by 10 to the power of minus 9. So 1 followed by 9 zeros nanometer is equal to 1 meter. So when you want to convert 1 nanometer in terms of meter, you're going to divide the value by 1 followed by 9 zeros. And next comes the kilo. Kilo is multiple. So 1000 meters is equal to 1 kilometer. Okay, so you're gonna multiply the values with 1000. So multiple means you're going to multiply the value, and submultiples means you're going to divide the values.
Now let's just look into few example sums based on multiples and submultiples of SI units. The first sum is you are going to convert 100 decimeter to meter. So you have already learnt the formula. 1 meter is equal to 10 decimeter. So here you are going to convert decimeter in terms of meter. So you are going to divide the value by, you are going to divide the value 100 by 10. So when we cancel out 0, you will be getting 10 meter. So this is the first sum. And the second sum is you are going to convert 200 centimeter to meter. So we know that 1 meter is equal to 100 centimeter. And if you want to convert centimeter in terms of meter, you are going to divide the value 200 by 100. So when we divide 200 by 100, we'll cancel the zeros. So 2 divided by 1 is 2 meter. So this is the answer for conversion of centimeter to meter. So the third one is we are going to convert meter to meter. So we know that 1 meter is equal to 1000 millimeter. So if you want to convert millimeter in terms of meter, you are going to divide the value 3000 by 1000. So when we divide 3000 by 1000, you are going to cancel the zeros and you will be getting 3 meter. So this is the answer for conversion of millimeter to meter. 19 followed by 9 zeros, 2, 3, 4, 5, 6, 7, 8, 9. 19 followed by 9 zeros, nanometer to meter. So we know that 1 meter is equal to 1 followed by 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9 nanometer. So if you want to convert nanometer in terms of meter, you are going to divide the value 19 followed by 9 zeros. 3, 4, 5, 6, 7, 8, 9 divided by 1 followed by 9 zeros. So you're going to divide. You're going to cancel all the zeros. So 19 divided by 1 is 19 meter. So next we are moved to the conversion of kilometer into meter. So you should convert 2 kilometer to meter. So 2 kilometer to meter. We know that 1 kilometer is equal to 1000 meters. So when you convert 2 kilometers in terms of meters, you are going to multiply the value because conversion of kilometer to meter is a multiple. So you are going to multiply the value. So the number 2 into 1000. So you will be getting 2 ones are 2 followed by 3 zeros meters. So this is the conversion of kilometer to meters.
Can you understand, students? So next we'll move on to the methods of measuring length of a curved line. A curved line cannot be measured by using a straight scale. Okay, so instead you're going to use a measuring tape or a thread to measure the curved line. So to measure a curved line using a thread, you must follow certain steps. So first is you're going to tie a knot at one end of the thread. So at one end of the thread, you are going to tie a knot and place the thread at the beginning of the line. And you must try to measure a small portion of the line which is straight. Can you understand? So you're going to place the thread at the beginning of the line and you're going to try to measure a small portion of the straight line. Okay, so next place your thumb at the other end of the measured portion and measure next straighter portion. So you're going to place your thumb at the other end of the portion and you're going to measure next straight portion. You're going to repeat the above steps till the end of the line is reached, and you're going to make a knot again at the end of the line. Now we are going to remove the thread and you're going to measure the length of the knots by using a scale. I'll just repeat it once again. So how do you measure the length of a curved line? A curved line cannot be measured by using a normal straight scale. Instead, you have to use a measuring tape or a thread to measure the curved line. So how do you measure the length of a curved line using a thread? You have to tie a knot at one end of the thread and place the thumb at the beginning of the line, and you have to try to measure a small portion of a straight line. And again you're going to place your thumb at the other end of the measured portion and you are going to repeat the process till the line is reached. After reaching the end line, you are going to make a knot again at the end of the line.
And now we are going to take out the thread, straighten it, and you are going to measure the length of the two knots on a scale.
Next, we'll move on to mass and weight. So what does mass mean? Mass is the measure of the amount of matter in an object, whereas weight is the gravitational pull experienced by the mass. Now, hold the sheet of paper in one hand and a book in another. Now, which hand feels the heaviness? The mass of the book is more than a single sheet of paper. Therefore, the pull on the book is more than that of the paper. Therefore, one hand has to give more force to hold the book than a paper force. What we experience is called heaviness. So, the SI unit of mass is kilogram and it is represented by kg. So what is the SI unit of mass? It is kilogram and it is represented by kg. So now a question. What is your mass? If you measure it in grams, it would be a huge number, right? So it is expressed in kilograms. So bigger weights are expressed in tons and metric tons. Can you get it? You can't measure your weight by grams because it would be a huge number. It would be a very big number. So you express in terms of kilograms. So bigger weights than kilograms are measured by using tons or metric ton. Now here is a few formulas. Okay, so 1 gram is equal to 1000 milligram and 1 kilogram is represented by 1000 grams and 1 ton is equal to 1000 kilograms. So you must know these values. It would be useful for conversion of values. Okay, students. So next we'll move on to the beam balance. So what does a beam balance mean? A beam balance is actually used to measure the mass. Okay. So a beam balance is a device used for the determination of the mass of a body under gravitation. So it is nothing but a device used to measure the mass of a body under gravitation. Works by comparing the mass of an object with that of known mass. Okay, so these are the pictures of a beam balance. You would have already seen this in many grocery shops. They would be weighing the groceries or the provisions you ask for using a beam balance, right? So beam balance is used for measuring mass. Next, we'll move on to the electronic balance. So what is an electronic balance? An electronic balance is a device used to find the accurate measurements of weight. How to say, it would be like exact measurement of an object. Okay, so it is used to find the exact measurement of weight, and it is very commonly used in laboratories for weighing chemicals. It is even used in many jewels shop to weigh the gram of the jewels, and it is used to weigh food and other grocery items. Okay, and it is mainly used in laboratories for weighing chemicals. Now, could you see the pictures here? So these are the electronic balances. The first picture, could you see a chemical is measured using a weigh balance, and the second picture you could measure the weight of the jewels by using an electronic balance. Next, we'll move on to time. Summer season changes into winter season changes to rainy, vice versa. So you all know that season also changed. We even know that time also passes. So how do we measure the passage of time? Yes, clocks are used to measure time. So here's the first image of a clock, and this type of clock we generally use it in our homes to find the time. Okay, but in earlier days people used sand clock and sundials to measure the passage of time during the day. So second picture is the sand clock, and the third picture is the sundial. So these two, sand clock and sundials, were used to measure the passage of time during the day in those days. And even one can measure time by using a vessel with a small hole. Okay, so now you can take a vessel or a bottle with a small hole in it and fill it with water. The time taken for the water to drain is used as a measuring device. So these are all just the rough methods for counting the passage of time. In these days, we used clocks to measure time, and in those earlier days, people used sand clock, sundials, and a vessel with water draining to calculate the time. We can also use electronic clock and stopwatch and other instruments to count even small duration of time. So electronic clocks are generally used in railway stations. You would have noticed, right? In railway station there would be a big digital clock. That big digital clock is nothing but the electronic clock, and the numbers will be displayed. The date, the time, their hour, minute, seconds, everything will be displayed. Okay, so that is an electronic clock, and you know that stopwatches are generally used to measure the smaller duration of time. For example, in PT class, when you run for 600 meters, your PT teacher will be recording your time using a stop clock. Okay, so the first two pictures are the images of an electronic clock, whereas the third and the fourth pictures are the images of a stopwatch. So electronic clock and stopwatch are generally used for measuring a smaller duration of time. You could even measure the seconds and the minute hands by using this electronic clock and stopwatch. Okay. So now we look into the fast facts. We have come to the end of the class. So these fast facts are listed in your textbooks. So now let's just know about these things. So the first one is an odometer is a device used for indicating distance traveled by an automobile. So generally calculating the distance traveled by an automobile, or what does an automobile means? For example, a car, a two-wheeler vehicle, lorry, that represents an automobile. Okay, so measuring the distance traveled by an automobile is generally calculated by an odometer device. So there's the picture of a odometer. Okay. The second one is the metric system was created by the French in the 19th. Okay. The third one is a ruler or a scale used nowadays is used to measure the length was invented by William Bedwell in 16th century. Then ruler, the small ruler you're using to draw lines in your classes, invented by William Bedwell in 16th century. Okay. And next one is the standard meter rod made up of alloy of platinum and iridium is placed of weight and measures in Paris. Okay. An alloy, a metal rod made of alloy of platinum and iridium, it is placed at Bureau of Weights and Measures in Paris. And copy of this metal rod is placed at National Physical Laboratory in Delhi. Okay, and the next one is 1 kilogram is equal to the mass of a certain bar of platinum and iridium alloy that has been kept since 1889 at the International Bureau of Weights and Measures in France. Okay, so 1 kilogram weight of a bar made up of platinum and iridium alloy has been kept since 1889 at International Bureau of Weights and Measures in Sevres, France. So that's it for today's class, students. So we have completed the unit 1, that is measurements. Now let us just do a review of what all we have learned in today's class. Okay, from the beginning, we'll just have a small go through. So first, you have learned what is measurement. Measurement is comparison of an unknown quantity with known quantity. So it is generally used in various fields such as sciences, engineering, construction and technical fields, and it has two parts, number and unit. And next we saw the measuring tools, the various measuring tools used to measure the various objects. Your height can be measured by using a measuring tape, a running time by using a stop clock, the size of a notebook can be measured by using a meter scale, and amount of water that you drink every day is measured by using a measuring jar. And next is the length. What does a length mean? It is nothing but the distance between one end and the other end measured in meter, and it is denoted by m. So for larger measurements such as for calculating the length between two cities, you can't say it as length between two cities. Instead you'll be saying it as calculating the distance between two cities is measured by using a kilometer. And for medium measurements such as if you want to measure your size of your notebook or the height of your cupboard, table, etc., it can be measured by using meters, and even smaller measurements are done by using centimeters and millimeters. And then we looked into the meters and the conversions, and we solved few examples in meters and the conversions, right? And next we looked into the SI units. So what does an SI unit mean? So SI unit is the abbreviated form of International System of Units. It is generally represented as SI units. So what are the basic measurements of SI units? They include the length, mass and time. SI unit of length is meter, SI unit of mass is kilogram, and SI unit of time is seconds. And in today's class we learned about multiples of SI units. So what does multiple and submultiples mean? Submultiple means you're going to divide the value, and multiple means you're going to multiply the values. And next we looked into the methods of measuring length of a curved line. We saw the mass and weight. So what is mass? Mass is the measure of matter in an object, whereas weight is the gravitational pull experienced by the mass. And you saw the SI unit of mass. So what is the SI unit of mass? Yes, it's kilogram, and it is generally represented by kg. And we saw few formulas That is 1 gram is equal to 1000 milligrams and 1 kilogram is equal to 1000 grams, 1 ton is equal to 1000 kilograms. And next we looked into the beam balance. So what does a beam balance mean? It is a device used to measure the mass of a body under gravitation. Okay, and you saw few images of beam balance. And next we looked into the electric balance. Electric balance is a device used to find the accurate measurement of weight. Where at all is electric balance used? Yes, it is very commonly used in laboratories to measure the chemicals, weight, food, other grocery items as well as jewelries. And next we looked into the time, the various clocks used in the earlier days and these days. So clocks are generally used to measure time, right? So in these modern days, you generally use clocks to measure time. In those olden days, sand clock and sundials were used to measure time. And we even saw the electronic clocks, stopwatches that are used to count even smaller durations of time. And we even saw the images of the various clocks. The sand clock you saw, sundials, electronic clocks, stopwatches. You saw the various images of clocks used. Next, you came to know about the various fast facts. So that's it for today, students. I have attached the worksheets for you. So kindly solve this in your notebook. Thank you, students.